All right, I got one more question. They asked me interval notation. What did you say? X plus 5 over 4x minus 3, and you're trying to find the domain. Okay. All right. Domain for rational equations. You do not want 0 in denominator. Does that make sense? So you have to say 4x minus 3 cannot be 0. Where is it 0? 4x equals 3, x equals 3/4. Alright? So I do not want x to be 3/4. Everything else is fine. 3/4 is out. How do I write this in interval notation? For interval notation, you have to always, whether or not you have bracket or parentheses, you have to have the small number on the left, big number on the right. So I want everything but 3/4. What is the smallest number you can have? Negative infinity. And negative infinity never takes a bracket. So you start with that. Where do you stop? 3/4, just to the left of that, right? And you do not want 3/4. Does that make sense? That's why you have to put a parenthesis. You don't want it. Then you go to the right of 3/4 and start again. How far can you go? To infinity. Union 3/4 to infinity. Do you see it? That's how it is in interval notation. Does it make sense? All right. The other thing that I was telling the class, I asked simultaneous equations with an x, y, and z with missing terms. What that means is, like, let's say I have x plus 2y plus z equals 5. I'm just making it up. Y minus z equals 7, and x plus z equals 5 or 6, or something like that. Something like this. I made it up. This may turn out to be ugly, but some that looks like this. So make sure you make that. You do that. The other one is solving in the longhand portion rational equations, and that is in the review. Okay. When you are solving rational equations, what do you need to watch out for? When you come up with the solution, let's say x equals 2. You just do all your work, you find x equals 2. Make sure you check your denominator. Make sure that that denominator, any denominator in the equation, is not becoming 0 when you put in 2. Let's say you have a bunch of things in the denominator. Let's say you have x minus 2. The problem is you said your solution is 2 and you put it in there and it makes your denominator 0. What that means is you cannot use that 2. That's an extraneous solution. So with rational equations, you have to watch out for whether or not that thing makes your denominator 0. And how do you solve rational equations? You have to find the LCM, so you have to be pretty comfortable with factoring. Multiply left and right with that, and then solve the equation. And with all this work, if you don't check the denominator, you may give me a solution that's no solution. After 30 minutes of working out a solution, and you got the wrong answer. So make sure that you check the denominator when you do it. So that's going to be in the longhand portion. And in my traditional class, I really did go over it. You guys, unfortunately, taught yourselves, and hopefully it's good, you know. So factoring trinomials, binomials with the cubes, and quadrinomials, terms, and that's with the grouping method. Be very, very comfortable with it. Yeah.
And are you going to tell me, like, your question, what's that, what have the answer of, like, factoring versus solving?
Not trick questions. I would just, yeah, I mean, it is hard to be tricked when you have the multiple choice.
Yeah.
Probably, that's not going to be a trick thing.
Okay.
But the only trick thing I can think of is like absolute value problems. Make sure that you understand those. Let's say I have this versus this. Can you do these problems? And what's wrong with the first problem? It's a negative. So you look at that, it's no solution. With this one, you're going to get a solution. With this one, you are not. So watch out for that with absolute values. Also this one. Let's say I do this versus I do this. There's a solution to that one, right? But what is the answer to this guy? When is an absolute value greater than a negative number? Always, that's right. So the answer to the first question is all real numbers. So that can be the only trick that I can think of with absolute values. Finding domain and range, doing complex rational expressions. Remember how those are? You know how to clean those up? Over x minus 1 over x squared plus 1, those kind of things. You know how to do those? The other one is simplifying rational expressions. I did ask quite a number of those. Let's say where it's going to sound like that. 2 over x minus 1 minus 2 over 1 minus x. What is that equal to? Now here is the trick thing, if you consider it trick. I know that 1 minus x simply is negative x minus 1. Do you see that? So you have to go and make that change. 3 over x minus 1 minus, now I'm going to put this in here, watch. There's a negative here, x minus 1, 2. And you have a double negative situation here, so that means 3 over x minus 1 plus 2 over x minus 1. The answer is 5 over x minus 1. So watch out for those opposite terms. Does that make sense? Do you know dependent system, inconsistent, those things, those words? I did ask that in multiple choice. Like dependent system, when you're doing simultaneous equations, what does that mean? Let's say 2 by 2, dependent system. You're going to have a line, and the other one is on top of it. It's not a separate line. Dependent system will have like infinitely many solutions. Independent system, it's going to be like this. They're going to crisscross. They're going to have two lines. That's one way to get independent system. Or you may have independent system that's parallel. They're both independent if you have two lines. But this one is dependent. You have only one line. Now, when they don't crisscross, they're parallel. What is the name of that system? Inconsistent. Alright? So review the terminology. Dependent, independent, consistent, inconsistent. When do you get one solution, infinitely many solutions, no solution? That's in the very first part of your simultaneous equation. I don't know what chapter that was. So the system in that 3 by 3, I did ask shading, so we did a shading problem, so it's in there. Multiplying, solving the formula. We do one more problem, so we got, let's make one up. We did one, and then I told you, watch out for the distributive property. So let's say, I'll give you another one. Let's say, I want you to solve for A. We have this situation. A equals C minus BA. I'm going to solve for A. How do you do that problem? A is like X, everything else is like a number, right? So you want A's on one side, everything else on the other side. So you have A plus BA. Does that make sense? And you're going to move the B on the other side. C minus BP. Yes? Now, here's the step. Be sure you know how to do this. A plus B equals C minus B. This is like a coefficient. So A equals C minus B over A plus little b. So pay attention to this step when you are using distributive property. Does it make sense? I don't think it's going to be that hard. So I'm going to put this video and the notes online. And I am in my office when? Okay, so Monday, Tuesday, Wednesday. So Wednesday is tomorrow. I'm in my office 12:15 to 2. And push comes to shove, I'm also here on Friday morning. I'm here for the mentoring engineers and stuff, but if you guys come, I'll take you in. Let's say last minute crisis questions. So I'll be here 11:30. 11:30, let me see. Yeah, 11:30 to 2. And my office is in B262D. It's on the B200 building, second floor. You get out of the elevator, you'll see my office. Okay? So Wednesday this time, and Friday this time. And then I'll see you guys Friday night. All right.